All right, guys. So today we are going to learn how to predict products of equations. So we're going to start in the synthesis section of reaction types. And I think I did a couple of these for you last time, but it's not going to hurt to do them again. So I'm going to start right here where we have the solids of aluminum and sulfur reacting to produce aluminum sulfide. So we have aluminum and we have sulfur. The next thing we've got to do is we've got to predict the charges that aluminum will have and the charges that sulfur will have. Okay, so aluminum, if you recall, is on one of our transition metals that is always a +3. So we don't have to have Roman numerals here. Sulfur, on the other hand, is a -2. It's right under oxygen, so it always has a -2. So the next thing we've got to do is we've got to figure out what ratio do I need to put +3s and -2s together so they add up to 0. That means I have to find the least common multiple between 2 and 3, which is 6. So how many aluminums, how many +3s do I need to get a +6 charge? Hopefully you said 2. So I need 2 aluminums. How many -2s or how many sulfurs do I need to get a -6 charge? 3. So 3 times -2 will be -6. So I'm going to need 3 sulfurs. So aluminum sulfide is Al2S3. Okay, now we've got our skeleton equation. Now we can go back and balance our equation. So always, always remember, write the formulas first. So write the formulas first. Make the skeleton equation first. Then once you've got that skeleton equation, then go back and balance. Okay? All right, so let's go back and balance. I've got 2 aluminum, so I need to multiply my aluminum by 2, and I've got 3 sulfur, so I need to multiply my sulfur by 3. Okay? All right, we got water, and we've got dinitrogen, so di means 2, and pent means 5, so 5 oxygens react to make nitric. X come from 8, so I'm looking for nitrate, which is NO3 -1. Now remember, we're balancing those charges with positive hydrogens. So I need 1 positive hydrogen and 1 nitrate to make nitric acid. Okay, so there's our skeleton. Now we're going to go back and we are going to balance it. So let's balance this. So I'm going to start actually with my nitrogens first. I've got 2 nitrogens here. So I've got 1 here. So I'm going to double this up. Okay. So let's now look at my hydrogens. I've got 2 hydrogens. 2 times 1 is 2. And then oxygens, I've got 1 plus 5, which is 6. 2 times 3 is 6. Okay. So always write the formulas first. Pay attention to your charges. Make sure that your charges equal 0. If it is a covalent compound, you don't have to pay attention to charges. Remember, it's covalent, okay, not ionic. Okay, decomposition. I think we did all of these already yesterday. So decomposition, remember, we're just breaking things down. So if I just have one thing on nickel metal hydroxide decomposes, I will usually tell you or give you some kind of a direction as to how it decomposes or what kind of thing you're looking at creating. Okay, single replacement. Let's look at these that we did not do yesterday. Okay, so for this one, we're going to use iron +2. Okay, so copper 2 sulfate. So iron +2 and copper is a +2 right here, and sulfate is a -2. It always helps me to put in charges first. Always, always put in your charges. So remember that positives replace positives right here, and negatives replace negatives. So do I have 2 positives that can switch? Or do I have 2 negatives that can switch? So hopefully you see that I've got iron that is a positive, and I've got copper that is a positive. So I've got two positives. The positives are going to switch. So iron is a +2, and sulfate is a -2. So I'm just going to need one of each, one iron and one sulfate to make iron 2 sulfate, and then copper is going to be left by itself. So there's a single replacement where we can actually predict. Okay, let's look at bromine and magnesium. So bromine, when it becomes an ion, it's going to have a -1 charge. Magnesium is in our second group, second column, alkali earth. It has a +2 charge, and calcium has a -1 charge. Okay, so now we have to think, do I have two positives that can switch places with each other, or do I have two negatives that can switch places with each other? I have two negatives in this case. So bromine and chlorine are going to switch places. Okay, now the thing that we have to remember is magnesium is a +2 and bromine is a -1. So what ratio do I need to put them together with? To balance that charge, magnesium +2 needs 2 bromines to balance out that charge, to add up to 0. And then remember, chlorine, when it's diatomic, it's diatomic. Remember our diatomic gases. We have bromine, iodide, nitrogen, chlorine, hydrogen, oxygen, and fluorine. They are all diatomic. So don't forget, if you have one of these that are just by themselves, elementally not bound to anything else, they are going to come in groups of 2. Okay, and aluminum. Okay, aluminum. Hey, L, we've got that. Silver, let's see, silver is one of our polyatomic, or not a polyatomics, one of our metals, our transition metals that always has a set charge. So it is a +1. Okay, so silver is a +1, and nitrate is NO3 -1. So when we put those together, we want 1 to 1. So I'm going to put this over here. We're getting pretty crowded. Aluminum plus silver nitrate. Okay, now aluminum, when we become an ion, aluminum becomes a +3. Silver is already a +1, and nitrate is a -1. So the question that you need to ask yourselves is, do I have two positives that can switch places, or do I have two negatives that can switch places? I have two positives. So silver and aluminum are going to switch places. We have to be aware, we have to be cognizant of the charge on aluminum and the charge on nitrate. Aluminum is a +3. Nitrate is a -1. So what ratio are we going to be able to put them together with? We're going to need 1 aluminum, and we're going to need 3 nitrates. +3 plus 3 times -1 equals 0. So 1 aluminum, parentheses NO3, close parentheses 3 for those aluminum nitrate. And then silver is going to be off by itself. Okay, so there's our skeleton. Now we need to go back and balance this. I've got 1 aluminum, 1 aluminum. I'm okay. I've got 1 silver and 1 silver. So far, I'm okay. I've got 1 nitrate group. Over here, I've got 3. So I need to come back and I need to multiply my silver nitrate by 3, which means I need to go back and multiply my silver by 3. Okay? So remember, when we are doing single replacements, positives will replace positives and negatives will replace negatives. Okay, double displacement. Everyone switches partners. Okay, so let's do some of these reactions. Okay, like I've been doing before, I always like to put in charges so I know what can switch places with what. Okay, so we're going to start right here where we have silver nitrate and sodium bromide. So silver has a positive 1 charge. Nitrate, if you look on your polyatomic table, it has a negative 1 charge. Okay? And sodium has a positive 1 charge, and bromine has a negative 1 charge. Okay? Now remember, positives have to bind with negatives. So silver has to bind with a negative. The only other negative that's in this equation that it can bind with is bromine. Silver is a positive 1, bromine is a negative 1. So we need a ratio of, 1 to 1. 1 silver and 1 bromine. Positive 1 plus negative 1 equals 0. Okay, now our other positive is sodium. The only other negative that it can bind with is nitrate. Sodium is a positive 1, nitrate is a negative 1, so we need a 1-to-1 ratio for this as well. Sodium plus 1 plus a negative 1 nitrate equals 0. Okay, so always do your skeleton first. There's our skeleton. Now we're going to balance it. 1 sodium, we're okay. 1 nitrate group, we're okay. 1 sodium, and 1 bromine. Okay, we're good. All right, calcium acetate reacting with ammonium carbonate. Let's put in our charges really quick. Okay, calcium has a charge of positive 2. Acetate has a charge of negative 1. Ammonium has a charge of positive 1, and carbonate has a charge of negative 2. Okay, so calcium has to get together with a negative to zero out. The only other negative it can get together with is carbonate. So carbonate is a negative 2, calcium's a positive 2, so what ratio are we going to use? Positive 2 plus negative 2 equals 0, so we need 1 of each. Calcium carbonate. Okay, now our other positive is ammonium. The only other negative that it can get together with is acetate. Ammonium is a positive 1. Acetate is a negative 1, so they are going to also get together on a 1-to-1 ratio. Positive 1 plus negative 1 equals 0. So here we go. Ammonium acetate. Okay, there's our skeleton. Now we are going to balance our equation. So let me get another color. So let's look at our stuff. We've got 1 calcium. We're okay. We've got 2 acetates. We've only got 1 acetate here. So let's multiply that by 2. We've got 2 ammoniums. Now we do have 2 ammoniums with that 2. And 1 carbonate and 1 carbonate. Okay, there we go. All right, lead 2. That means this lead is charged plus 2. Nitrate, if you have your polyatomic sheet handy, is NO3 negative 1. So what ratio? Positive 2 plus negative 1 do I need? Did you say 1 lead and 2 nitrates? If you did, you're correct. 1 lead and 2 nitrates. Okay, sodium. Sodium is a positive 1. Iodide is a negative 1. So they are going to get together on a 1-to-1 ratio. NaI. All right, we've already got the charges put in. So lead is a positive, so it has to get together with a negative. The only other negative that we have here is iodide, right? And if lead is a positive 2 and iodide is a negative 1, I'm going to need what ratio? Did you say 1 lead and 2 iodide to get it to add up to 0? Hopefully you did. And sodium, the only other negative for it to get together with is nitrate. Sodium is a positive 1. Nitrate is a negative 1. So they are going to get together in a 1-to-1 ratio. Okay, so there's my skeleton. Now I'm going to go and I am going to balance this with some coefficients. Okay, so I've got one lead and I've got one lead, so I'm okay. I've got two nitrate groups here and I've got one nitrate group. So I need to multiply this nitrate group by 2. So I'm going to multiply this by 2 if my computer will actually let me write. So sodium nitrate needs to be multiplied by 2. And then let's see, I need to go back and multiply my sodiums by 2. Okay, so 2 sodiums, 2 sodiums, 2 iodines, and 2 iodines. So there I go. So 1 lead nitrate, 2 sodium iodines gives me 1 lead 2 iodine and 2 sodium nitrates. Okay, last but not least, potassium hydroxide. Potassium is a positive 1. Hydroxide is a negative 1. Hydrogen, we're going to pretend, well, it is a positive 1 in this case, and the sulfate group is a negative 2. So positives have to get together with negatives. So the only thing that potassium can get together with, other than hydroxide, is sulfate. Positive 1 plus a negative 2, I'm going to need 2 potassiums and 1 sulfate group. And then water is actually made with hydrogen and OH. So HOH will simplify to water. Okay, when we balance it though, I want you to think of it as HOH. It's lots easier to balance it like that. But when you write it for your final, write it as water. So let's balance this. There's our skeleton. Let's balance it. So if I look at my potassiums, I've got 1 potassium here, I've got 2 here. So I need to double this. Okay? Now I'm going to look at my sulfate group. I've got 1 sulfate group and I've got 1 sulfate group. So I'm okay. Now let's look at my hydroxide groups. I've got 2 hydroxide groups. So I need to have 2 hydroxide groups. So I'm going to double this. I have 2 hydrogens, so I've also doubled my 2 hydrogens. So that gives me 2 waters. So I'm going to write that as 2 waters. So when we're all said and done, we will have potassium sulfate and 2 waters. Okay, if you want to use HOH to help you balancing and then rewrite it to waters, go right ahead. That makes things a little bit easier. Okay, combustion. Let's do some examples of combustion. So acetone. Acetone is C3H6O, and we're going to burn it in the presence of oxygen. And our products are always, always carbon dioxide and water. Okay, so remember, we always do carbons first, hydrogen second, and oxygens last. So we're going to look at our carbons first. Okay, so I've got 3 carbons right here. I need to multiply my carbon dioxide by 3. Okay. And I've got 6 hydrogens, so 6 divided by 2 will be 3, so 3 waters. Okay, so let's look at my oxygens on this side. 3 times 2 gives me 6, plus 3 more gives me 9 total. Okay, I've got 1 here. So let's see, 9 minus 1 equals 8. So 8 divided by 2 is 4. So 4 times 2 is 8, plus 1 is 9. That gives me 9 and 9. Cellular respiration. Do you guys remember that from biology? We started with glucose. Do you guys remember the Krebs cycle? C6H12O6. And you are breathing in oxygen. you are breathing out carbon dioxide and water. Okay, so where are we going to start first? We are going to start with our carbons. Okay, carbon. I've got 6 carbons. I need to multiply my carbon dioxide by 6. Then hydrogens, 12 hydrogens. 12 divided by 2 is 6, so 6 waters. Okay, let's look at our oxygens on our product side. 6 times 2 gives me 12. 6 times 1 gives me 6 more. That gives me 18. Okay, on my reactant side, I've already got 6. So 18 minus 6 gives me 12. 12 divided by 2 is 6, so I need 6 oxygens. That will give me 12 more, so 18 and 18 on both sides. Okay, so we already went back and we did reaction types. So let's do some more balanced chemical equations with these predicting reactions. So magnesium and nitrogen. So magnesium, when it has a charge, when it acquires a charge, it is going to acquire a +2. And nitrogen is diatomic, but when it acquires a charge, it's going to be nitrogen +3. Okay? So, how do I put 2s and 3s together? We have a least common multiple of 6. So, how many magnesiums do I need to get to a +6? I need 3, right? And how many nitrogens do I need to get to a -6? 2 times -3 is 6. Okay, so there's my skeleton is going to be magnesium plus nitrogen, because nitrogen, remember, is one of our diatomic molecules. So we've got our skeleton. What are the coefficients we need? So I've got one magnesium and 3 magnesiums over here. So I need to multiply this by 3. I've got 2 nitrogens and, oops, I should have put a 2 here. Oh my gosh, I'm losing it. 2 nitrogens there, so we're good. So all we had to do was put a 3 there. Okay, so we have C3H8, which otherwise known as propane. So this is what you're burning when you have your propane grill, and we've got oxygen. So C3H8 plus oxygen gas, O2. Remember, oxygen is diatomic. Okay, so I have something made of just hydrogen and carbon, and I've got oxygen here. So what kind of reaction do we have? We have a combustion. So this is going to be CO2 and H2O. Okay, so let's write this on the side. This is combustion. By the way, let's go back up top to A and tell me what type of reaction it is. I've got 2 elements and I'm putting them together to make something more complex. So what do you think? Did you say synthesis? Yep, that is a synthesis reaction. Okay, so let's go down to B. We've got our skeleton. Now we need to balance this. Okay, so let's balance this. We've got 3 carbons on our reactant side, and I've only got 1, so I need to multiply this by 3. Okay, I've got 8 hydrogens here. 8 divided by 2 gives me 4. Okay, let's look at my oxygens now. 3 times 2 gives me 6, plus 4 gives me 10. Okay, 10 divided by 2 gives me 5. So there we go. All right, cobalt 2. So our cobalt is charged +2. Oxygen is a -2. So what ratio are we going to use? 1:1, did you say? Cobalt and oxide. I have nothing else going on. So what's the only thing that I can do if I have a compound and nothing else is going on? I can break it down. That's the only thing I can do. So I would have cobalt and oxygen gas. And remember, oxygen is diatomic, so it has to come in groups of 2. Okay, so we're breaking down a compound. So this is going to be decomposition. Okay, so let's balance this. How many cobalts do I have? 1 and 1. I'm okay. 1 oxygen, 2 oxygen. So I need to go back and I need to double my cobalt 2 oxide. Okay? Next, we got calcium and copper 2 bromide. So let's put in our charges. Calcium will acquire a +2 charge. Okay, copper 2 is already a +2, and bromine is a -1. Okay, so we're going to write our skeleton here. Copper is going to get together with bromine on a 1:2 ratio. Do you guys agree with this? Copper 2 bromide, CuBr. Okay, now the next thing that we've got to decide, do I have 2 positives that can switch places, or do I have 2 negatives that can switch places? Hopefully you said I have 2 positives. So yeah, calcium is going to switch places with copper. Okay, so calcium is a +2, bromine is a -1. So what ratio do I need to put them together? Hopefully you said 1 calcium and 2 bromines. This will stop thinking and let me write. So one thing about Screencastify, it gets really, really laggy. Really laggy. I don't know why it gets so caught so behind. Okay, so let's try this. So calcium +2 with bromine that is a -1. So we're going to need 2 bromines. Come on, it just spent a ton of time thinking. Oh, yay. And now my Headley has decided to start installing its update. Fabulous. Okay, so calcium bromide, we're going to need 2 bromines. And then copper is going to be by itself. Okay, so there's our skeleton. So we can tell that calcium and copper are switching places. So because calcium and copper are switching places, we know that this is a single replacement or displacement. Okay, so let's balance this. So 1 calcium, we're okay. 1 copper, we're okay. 2 bromines, we are okay. This is one of the rare times where our skeleton is actually going to be our balanced chemical equation. Okay, magnesium. Magnesium will acquire a +2 charge once it becomes an ion. Silver is a +1 and nitrate is a -1. So silver +1, nitrate -1, they'll go together on a 1-to-1 ratio. Now, the thing that we have to understand or decide is, do I have 2 positives that can switch or 2 negatives that can switch? Hopefully you said we have 2 positives that can switch places. So the magnesium now is going to get together with the nitrate. We need to decide the ratio. Magnesium is a +2, nitrate is a -1. So in order to get that to add up to 0, I'm going to need 1 magnesium and 2 nitrates. And then silver is going to be off by its lonesome. Okay? So this is also a single displacement. Okay? Now let's go back and balance this. So I've got one magnesium. That's okay. One silver, one nitrate, two nitrates. I need to double this up, which means I also need to go and double up my silver. Okay, lithium chromate. Okay, lithium chromate. Let's kill that. Lithium chromate. So lithium is a +1, and chromate is CrO4 -2. Okay, so what ratio do they need to go together in? Did you say 2 lithiums? Yeah. And barium is a +2, and chloride is chlorine, which is a -1. So you need 1 barium and 2 chlorines. Okay, I have 2 positives and 2 negatives, so they can switch places with each other. So lithium is going to get together with the chlorine. Lithium's +1, chlorine's a -1, so 1-to-1 ratio there. And barium's going to get together with the chromate. Barium's a +2, and chromate is a -2, so a 1-to-1 ratio there. So there's my skeleton. Now we've decided that everyone switched partners, didn't they? So this is a double displacement or a replacement. Okay, so let's balance this. 2 lithiums, 1 lithium. So I need to double that up. 1 chromate group, 1 chromate group. 1 barium, 1 barium. 2 chlorines, 2 times 1 is 2 chlorines. All right, iron fluoride. We're going to use iron +3 here. If it will let me do this. So iron +3, what did this just do?